Hello, this is Kid. Another day, another video. Now, this video is on differentiation, more particularly a type of question of differentiation, a type of application called optimization. So I'll be showing you how to do two past paper questions. And yes, this is the first time I show my face on this YouTube channel. But that is because the following video, the following analysis of the question paper is actually a segment of a math course that I did on Udemy. So if you like the style of this video and you want a more in-depth lecture or a course, a complete course actually, on the topic of calculus, so both differentiation and integration, based on the new AASL syllabus, IB, then you really should go check out my course on Udemy. If not, I still hope this video can help you. But if you're interested to go to Udemy, you can check out the link in the description. I will put a code there. The first 20 people that go get my course can get it at half the price. So please go and have it if you need it. And it'll be nice if you leave me a review. Hope you enjoy the video. Okay, in this lecture, we're going to go through a type of question in differentiation called optimization. Okay, optimization really means finding maximum and or the minimum, but in a real life situation. Okay, so we'll go straight into a past paper question. This is a question from 2016, and it's in paper 1. But this could totally happen in paper 2 as well. You would basically do the same thing, except obviously when you're solving for equations, you could use the GDC, but not much difference there. Not too big a difference. Okay, so let's dive into the question. So in the question, there is a container, and there's always something that they want you to optimize. So there is always something that they want you to find the maximum or minimum of. And in this case, it is AX. Okay, where AX is the surface area of the container. And if you read the question in part C, we're going to find the minimum of AX. Okay, so we'll find the minimum of this thing. So in doing optimization, the process is pretty standard. Whatever you're trying to minimize or maximize, so whatever you're trying to optimize, you should first find an equation of that thing. So that's what part A is about. You are supposed to find an equation of the surface area. Okay? And the question is show that it is just being nice, just in case you couldn't figure this out, you can still use this answer to go on to do part B and C and D. Okay, but while you are doing part A, you are not supposed to use this answer to help you do part A. Okay, so in the perspective of just part A, you're really finding AX. Okay, so you want to find the surface area of the above container. So it should be easy, surface area, right? So you just find each of the area. So this piece is obviously have an area of x times x, base times height, right? So x times x is x squared. While the opposite side is the same. So we have two of those. Plus maybe we have the bottom piece, which is x times y. Okay. While for this question, you need to be careful. The top here, there's no cover. How do I know that? Because it says an open container. Okay, so that's the tiny little trick there. It's open, so there's only 1xy. There's no need for the top. And then plus, you can have this side, which happens to be also xy. But for this side, you have the back. The back is also there, so it's 2xy. So AX is basically 2x squared plus 3xy. Okay? Now the problem is, if you just do this, there is two unknowns. There's x and y. Okay? In this level, whenever you're doing optimization, this is bad. This is really bad. Why? Because if there's two unknowns, you won't be able to differentiate it, which is what you would do to find maximum and minimum, right? So even if this part B doesn't exist, you would know you should differentiate if it's a paper 1. If they don't ask you to differentiate, in the paper 2, you could have just use a GDC, plot AX and look for the maximum on the graph. But similarly, you cannot plot something with two unknowns, but with both x and y, so it's really having the same problem. That is why there is the information about the volume being 36. Okay, so this is not here to distract you. This is actually useful. Okay, so this is where we would look at how do you calculate the volume. So for this time, it's easy. Volume is just base times length times height. So the volume is obviously x times y, which is given to be 36. What that means is x squared times y is 36. Okay? Now, if you look at the answer that they want, look at the show, which at the very end, the answer should look like that. There is no y. There's no y in the answer. What that means is, with the extra information on the volume, you should make y the subject. Make y the subject. And then you substitute this information into the function that you're looking for, into the function that you're trying to optimize. Okay? So you always use this extra information to get rid of one of the unknown in the function that you're trying to optimize. This is a very classic setup for optimization. So y is indeed 36 over x squared. So it's 2x squared. So we multiply them together. 3 times 36 should be 108. And we have x over x squared. One of the x cancel out. So it's 108 over x. Okay? Which is what they want. Then they ask us to differentiate. This is why this question could still happen in paper 2, because they would force you to, they could have a part to force you to differentiate it, rather than you just graph it and ask for the maximum using the function in the GDC. So so obviously you still need to do it. So let's do it here, part B. So AX is 108 over x plus 2x squared. In order to differentiate it, we know we should write 108 over x as x to the power of minus 1 plus 2x squared. You really should know this, otherwise you should visit the basics of this course. So that's differentiated. So that should be it for part B. Part C, find the minimum. I mean, it's more like find the height when the area is minimum, where the height is really x. So we should find out what x is, such that AX, such that this thing would be minimum. Well, that's easy to find minimum. So this is part C. To find minimum, we want the derivative to be 0. So we would put this negative 108 x to the power of negative 2 to the right hand side, so it become positive. Okay, this is where solving this equation is a bit tricky. You would turn the x to the power of negative 2 back to a fraction. So negative power means over x squared, and then multiply the x squared to the left. So we have x times x squared, that's x cubed, and then you divide the 4, which will get 27. And so you take the cube root of 27, x is 3. So when the height is 3, you obtained minimum. Done. The question didn't ask you to justify that it is a minimum, so we probably won't do it. But well, just to show you, if you would justify it, how would you justified. You could use the first derivative test, right? So the first derivative test, what you do is you do a sign diagram. So you have 3, so you test something less than 3, test something bigger than 3, and you would plug your value into the first derivative, which is this one, the first derivative. So let's do it. Let's plug something less than 3. Okay, let's say 2, so it's negative 108. Again, x to the power of negative 2 means over x squared, over 2 squared, plus 4 times 2, so it's 8. So again, 108 over 4, because 2 squared is 4, it's negative 27 plus 8, so that's negative. Right, when it's 3 is 0, because we solved for 0, bigger than 3, so let's say 4, plus 4 times 4, so you just plug it in, right? So 4 squared is like 16, so negative 108 over 16, plus 16, what's 108 over 16? Now this is why this question didn't ask you to do it, because 108 divided by 16, not the easiest thing to do with our calculator. You can do it, but I don't think IB care about that. Okay, that's not the point of IB. But anyway, it should be positive. So it's negative and then positive. That means this is a minimum. Okay, so which is what it's supposed to be. Again, this question did not ask you to do this. I'm just doing it to show you, just in case. And obviously, we could also do the second derivative test. Let's show you again. So we have the first derivative being, what is it? It's negative 108 x to the power negative 2 plus 4x. You may have to rewind the video a little bit to follow if I'm too fast. Yeah, feel free to do it. So you can you differentiate it? So I hope you can follow. You drop the negative 2, so negative, negative, positive. 2 times 108 is 216, x to the power of negative 3, because you take away 1 from the power, plus differentiate 4x is 4. And then what you do is you plug in the value you found, which is this value, into the second derivative. Again, not the easiest thing to do without a calculator, which is again probably why they won't ask you to do it. So let's do it. Times 3 to the power of negative 3, that's over 27, plus 4, you should get 12, okay? Which is positive, which of course should be, because it's a minimum. So this is how you would justify it if the question asks for it. Okay? Which they did not, but it's fine. Lastly, Fred paints the container with a paint. So every 10 meters square, it would cost $20. Find the total cost. Okay, so we need to find the area, right? So we know the height is 3 now. So the area is A3. Area is here, obviously. Over 3 plus Okay, it expects you to do this by hand, so that's 36 plus 3 squared is 9 times 18. Times 2 is 18. They add them up is 44. But each teen only cover 10 cm meter, so 4 teens would not be enough, so we need 5. So therefore we need 5 teens. And each costs $20. So at the end, I'll need $100. Wow, baby math, what should I say, right? 5 free marks. Yeah, so that's an extremely typical optimization question. This type of question is not exactly popular in IB, but it comes out once in a while, so should be prepared. So this one is actually pretty tricky, it's pretty hard 2017. It's a November question. So I don't know if you know, but personally, I agree with it. The November paper are a bit harder than the May paper. Yeah, I don't know why they do that. So this one is a particularly tough question. They tell you a function f. They tell you the equation. It's a quadratic. Then inside the graph there is a rectangle with point A on the negative x-axis, and then B is on the curve, and then you basically use that to form a rectangle. Right? The question is, what is the maximum area of this rectangle? Okay? Or at least what is the x-coordinate of A such that this area would be maximum? Now this is a particularly tricky question because there's no parts, there's no tips whatsoever, and the first step is very tricky. So if you don't even know what to do the first step, you lose 7 marks automatically, 0. There's nothing you can do if you don't know how to start this question. I encourage you to pause the video now and give it some thoughts, give it a try. Okay, so this is a 7-mark question, which means on average you should finish the whole question in 7 minutes. Which obviously you probably need to think for a little bit while to get it. So I would say maybe thinking for 4 to 5 minutes would be reasonable, because once you get the first step, the remaining is not that hard. But if you spend like 10 minutes thinking about this, you probably spend too long, because that would mean you may not have enough time to do the section B's, which is bad, because maybe some easier stuff is there. Right? So I suggest you to pause the video right now for like 5 minutes, give it some thoughts. If you really have no clue, come back. I'll give you the first hint. Okay? So see you in 5. Okay, the hint is coming. 3, 2, 1. The question is, what is the x-coordinate of A, right? So the first thing to do is you let the x-coordinate of A to be some variable. You could just call it x. So call the x-coordinate of xx. Okay. Okay. Now, same as before. Whatever you're trying to optimize, like if you're trying to optimize ax, what's the first thing you do? You find a formula or find an equation for ax. So you need to find a formula for what you want to maximize or minimize. So now your goal is to find a equation for the area of this. Okay? Now if this is x, if this x-coordinate is x, then it should be quite obvious that the width of this rectangle is x. Okay? So in order to find the area of this rectangle, your next problem is, what is the height of the rectangle? So now give it some thought again. Give yourself an extra 1 minute. Try to see if you can guess. Let me show you the whole question. What is the height of this rectangle? See you in a minute. Okay, the answer will be coming. 3, 2, 1. Now turn out the height is just the function. Right? Because if I tell you A have x-coordinate x, then B must also have x-coordinate x, because they have the same x-coordinate. But if you know the x-coordinate of it, how do you find the y-coordinate of a point? Well, this point is on this function. If it's on the function, you find the y-coordinate by plugging in the x-coordinate. So if you put x into the function, you find the y-coordinate of that point. If you put x into 15 minus x squared, you get exactly 15 minus x squared. And if you have the y coordinates of this point, you have the height of this point, which is also the height of the rectangle. So this is the trick. So the area is actually the width, which is x, times the height, which is the function. Okay? And again, as I said, if you don't know this trick, there's nothing you can do for this question. You just lose 7 marks. It's cold. This is cold. November have always been tough. And by the way, this question, this trick, happened again in 2019. So yeah, I'd be like that. You know, the first time they give you something really hard, almost nobody get it. Very soon they would basically do the same thing again, you know, see if the students learn from it, right? So the area is just expand, and obviously to find the maximum, we can call the area A. To find the maximum, you would differentiate this. So differentiate this, make it 0. So move the negative 3 squared to the right, become positive, divide by 3. So x is plus or minus square root of 5. Again, remember the plus minus. Question is, what is the x coordinate of A? While A is negative, therefore the coordinate of A is negative with 5. That's it. Cold-blooded 7 marks. But again, this is it. Optimization. The goal, the key, you need to find a formula or an equation for the thing you try to maximize or minimize. And when you find it, it has to be something with only one unknown. If you have 2 unknowns, it must be because the question gave you an extra information to substitute in to the unknown. And when you have found the equation, you differentiate it like you would do for finding maximum and or minimum. If you have to, you will need to justify it if the question asks for it, right? And this is it. This is basically it for optimization.